Assalamualaikum. Hi, I'm Nur Fatihah binti Abdul Rahman, and I'll be presenting my research project entitled The Investigation of Few Properties of Residential Food Waste under supervision of two supervisors, which are Nur Mariza Ahmad and Dr. This is the poster that I've prepared for this presentation. My presentation will start with the introduction of this topic of research, and then followed by the problem statement, objectives, the scope of research, methodology that has been used throughout this study, as well as the results and discussion before conclusions and references. So what is actually residential food waste? Residential food waste is also known as the domestic waste or household waste. So these are the waste that are coming from our homes, including the kitchens and the yard remains. So these waste is resulted from the human activities nearby residential areas. That's why it is called residential food waste. As for the introduction of this study, in UK, the largest amount of municipal solid waste after paper and yard remains, it is actually the food waste. It sounds serious, right? So, if you'd like to take a look within the Malaysia itself, in 2019, Solid Waste Corporation said that Malaysia actually generates 16,000 tons of food waste daily, which is actually enough to feed around 12 million people 3 times per day. Food and Agriculture Organization states that there are about 1.3 billion tons of food waste discarded per year by the global population, and this amount is actually enough to feed around 850 million people that are hungry. So, Food and Agriculture Organization states that there are about 1.3 billion tons of food waste discarded per year by the global population, and this amount is actually enough to feed around 850 million people that are hungry. So, besides, the World Bank also reported that there are currently 2.01 billion tons of food waste discarded by the world population up to 2016. And it is estimated that around 3.4 billion tons of food waste will be discarded and ended up in the landfill if there is no control measure being executed. These report and facts are actually a wake-up call for global population to stop producing food waste. So we have to work out any control measure that is effective enough to convert this waste into energy or brings out money from our waste. Problem statement number 1. There is always a constant increase in managing. Problem statement number 1. There is always a constant increase in the residential food waste management demand due to the increasing amount of waste generated over the years, such as the leftovers or the overripe food. Number 2, there is no definite measures that are proven to be effective in managing those residential food waste. And number 3, it is because of the limited resources that can be found on this food waste characterization that is important to tackle this phenomenon. Objective of this study, firstly, is to analyze and evaluate the physical properties of this food waste by focusing on their ash, moisture, and fixed carbon content, and their volatility matter by monitoring changes in weight using thermogravimetric analyzer. Next, it is to measure the heating value and the calorific content of this food waste using warm calorimeter, and reviewing their chemical composition alongside functional group determination using FTIR. And lastly, it is to compare the actual and predicted higher heating value using HHV correlations from 10 different equations. For your information, methodology of this research project include a series of steps. It starts with sample preparation and then proceed to sample analysis before HHV determination and correlation. So in the sample preparation, 6 different food waste sample are being prepared in both wet and dry condition. So these 6 food samples are meat samples, bone samples, rice, bread, vegetables, and lastly a mixture of these 5 different food waste samples. So once being prepared, only dry sample will be used for FTIR and bone calorimeter analysis, but both wet and dry food sample will be used for TGA. So once preparation is done, the sample will then be proceeded to be analyzed. So it will be analyzed for proximate analysis using TGA and functional group determination using FTIR. Once done, the dry sample will be analyzed using bone calorimeter to measure its calorific value. And then the obtained calorific value from the bone calorimeter will be compared with the predicted calorific value or higher heating value using 10 different HHV correlations. So let's take a look at the TGA results. We can see that there is a negative value of the ash content percentage of the wet sample of rice. So due to this negative value, it is impossible to determine the fixed carbon content of the wet sample of rice. Therefore, for rice sample, only dry sample will be processed and further analyzed. So for the moisture content percentage, it is obvious that the moisture content percentage in wet sample type would be higher than the dry sample. This is due to the higher water content in the wet sample type than the dry one. And except for the meat and mixed waste sample, the volatimeter of wet sample is seen to be higher in numbers as compared to the dry sample. And comparatively, ash content percentage in the dry sample of most of the waste type is higher than the wet type of sample, especially for the meat. And the fixed carbon content of the wet bone sample is proved to be higher than the wet sample. However, there is a different case for any other type of sample where the dry food sample have more fixed carbon than the wet sample type. Different type of waste truly emits a lot of differences as compared to each other. And in overall, a sample or the food waste sample with a lesser moisture, a higher volatimeter, and a lower ash content would make a good sample for combustion. For the calorific value determination, there is a variable of storage time of day 1, day 3, and day 5. So only bones and the vegetable samples are showing an increased calorific value over a period of time, while other samples such as the meat, rice, bread, and mixed waste decreases its calorific value over a period of time. So this is telling us that storing bones and vegetable samples, bones and vegetable waste for a little bit of time before being combust will make a good choice for to produce a more energy amount for combustion. For the higher heating value correlation, the actual calorific value of the food waste sample will be compared with predicted HAV that is obtained from 10 different HHV correlation equations. So from the table, we can see that equation 2, equation 8 and 10 is clearly cannot be used because of their value is far too different from the actual calorific value of the sample, which is being measured by the bone calorimeter. Therefore, this equation is invalid to be applied in this study. And as far as we can see, it is equation 5, 6, and 7 is still applicable and the most suitable equation for predicting HHV for the residential food waste type in this study, because the value of their predicted HHV is still within the range of the actual calorific value of the residential food waste sample that we used to measure in this study. As for the CHNSO, which is the elemental composition of this food waste type, except for the bread sample, all elemental composition Let's take a look at the TGA results. We can see that there is a negative value of all elemental composition, which is the carbon, hydrogen, nitrogen, sulfur, and oxygen content of this sample are obtained from previous research, which is related to the food waste characterization. For the To conclude, resorting residential food waste as an alternative solid fuel is always a good choice, as they have the capability of generating solid fuel without causing notable harm to the environment. Meat is seen as the most reliable source of fuel, as well as the others food waste type. And it is advisable to not expose the sample to the environment or any moisture, so that the accuracy of the result can be controlled. And repeated series of experiment would help to increase or improve the accuracy of the results. And that's all from me. Thank you.